really small. What does it mean to have matched pair data? And that's when it's taken from, they gave the example of what, like the pre-test, post-test, or I can't remember what other example they gave. It's where it's drawn from the same individuals selected for the sample.
Mm-hmm.
Yeah.
And then the difference in the hypothesis test between one sample, sigma unknown, and matched pairs. Isn't it just that the difference is in the paired sample, you're taking the difference, you're using the difference?
Yeah.
Yeah.
So the one sample is the t equals x minus null hypothesis over s divided by the square root of n. And then the paired one is the d minus 0 over, what is that, like sample times d, the s d over square root of n? Am I right or wrong here? I just put the two different equations down.
That's right.
Yeah.
Did you write something different?
I just wrote that you have to take the difference first.
Yeah. Basically.
Okay.
Sorry guys, it took me forever to get on. I couldn't find the right thing.
Yeah, it's harder than I thought trying to join one of these video chats.
I know.
I
And
didn't work it very good.
I heard the call thing, but I couldn't see it on the computer. It was just doing it on my phone. Usually I just answer if someone, does the call, but.
Oh, is that what it is? I set it up. I don't really know how to work it very well.
Yeah, it's kind of hard to find people, but.
So where are we at right now?
We just went over our answers on part 1, so now we'll start part 2.
Perfect.
Do you have questions on part 1?
Not really. I keep on going to the tutor.
Cool.
Makes it kind of answer all the questions. Our test is next week, right?
So,
Really?
like on the 6th?
Yeah. No.
No, it's next week and it's due next Saturday.
Yeah. Next Saturday.
Oh, yeah.
Okay. Part 2. Design the study.
So, a manager at a factory feels that the amount of time that his workers spend doing their part in the assembly line is too long. To determine if a new assembly procedure is effective in reducing the time, he measures the amount of time in minutes 9 of his workers take to complete 100 products. After implementing the new procedure, he again measures the amount of time in minutes the same 9 workers take to complete 100 products and obtains the following data. He wants to know if the mean assembly time is different and use the level of significance of 0.5. And then we need to go to factory assembly times for SPSS to do it. So number 1, what is the research question?
Does the, I guess, changes in whatever he did to the factory affect the time it takes to assemble the parts?
Yep.
Yeah.
And state the null and alternative hypotheses. So
So how do you do this?
Um, well, first we're just getting ready, and then we'll put it into SPSS. But isn't this just like it's equal to or not equal or greater than or less than?
Okay.
Yeah. I think the null is that the difference will be 0, right?
Because
Or
there's
the-
100 products.
Yeah, so the null is like it won't make much of a difference at all.
In
Uh-uh.
time,
The
right?
alternative is that it will make it faster. So less than 0.
Is it less than or not equal to?
Not equal to 0. That's
Not
what
equal.
you're going to put, because you can't really put less than 0, can you?
I think so. Well, because he wants to know if it'll make it faster. It will reduce the time.
Yeah, but I'm pretty sure you can't make the time less than 0.
Well, I'm not saying the time is going to be 0. I'm going to say the difference between the times.
I don't know. I guess I just don't know how to put a less than 0.
Yeah.
I've been taught that that's wrong.
Let's see. I don't know. How would you say that? That the
Not
Mhm.
equal to 0, I thought.
be not equal to 0? Okay.
We lost Amy, it looks like.
Uh-oh.
How's her internet doing? Do you guys know?
It was fine, I thought.
Did she send a message at all? Can you guys hear me at all?
Yeah,
She put
oh, no.
no. Sorry.
Oh, there we go.
She said, "Ugh, I don't know what's wrong with my computer." So I'm just gonna send her like, you keep on going with this, and I'll check back every once in a while if you have any questions. Is that cool?
Yeah, so she can she hear us then?
Can you hear us? I would imagine if she can, then she would respond. She
Oh.
said no. Well, then I would. Okay. She said, but the sound is working on my computer. I'm just gonna ask her to write down all of her answers, like, and send him like through this, like watch out for each individual answer. wonder if these people can... Yeah, she hasn't responded yet. I think she's trying to fix it. Let's just keep on going, and
Okay.
then I'll keep an eye on this.
All right.
Okay.
So
I just read the question wrong. It does say he wants to know if the time is different. So yeah, it would be not equal to 0.
okay. The number 2, collect the data. Describe the data collection procedures. The data is just the time change from before and after the implementation of the new procedure, right? From the 9 workers.
Yeah. Okay. Yeah, so they took the same workers, had them do 100 products before and then 100 products after the changes, and then measured the times.
All right.
Okay. Describe the data. In a short paragraph, use summary statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data.
So how do we do that? We use the formula, like,
I guess, yeah. Oh, is that like the summary statistics? Is that like they want the mean and they want the...
Exactly.
Oh, okay. Let's see here.
that's what they want?
I think so. Is that what it is? I don't know what it's asking for.
What paragraph is this?
I thought it was a comparison of both the new and the old. So, for example, you have your mean of your first, then you have your mean of your second. Is that wrong?
Let me look. I don't really know what it's asking for. I'm going to look at the answer key.
I don't either.
Okay, so describe the data. Okay, it just says students should have a paragraph to summarize the statistics. They should include... Okay, so the mean difference, the sample standard deviation difference of the difference, and the number, which is 9. Okay, so yeah, they just wanted like the mean, the standard deviation, and the number.
Oh.
And it
Perfect.
also says include a histogram of the differences and a histogram of each of the original data sets.
So we're using the I guess, so then we go on to that factory assembly times,
Yeah,
CSS, to get all of this.
yeah, you have to get the SPSS pulled up. And let's see. So which one are you guys doing first? Are you doing the pre minus the post or the post minus the pre?
I'm doing the pre minus the post. Is that wrong?
I
Does it matter?
I have no idea. Because I feel like you'd get the same answer, just one would be...
Yeah, one would be positive and one would be negative.
Yeah.
Same.
I just ate so much chicken. It's fantastic. They have that deal at Albertsons on Monday here. and you
Huh?
get 10 pieces of chicken for $4.
Wow.
Nice.
Is that like an all-day thing?
Yeah. You go there, and if you pay an extra $2, then you get 4 rolls and sides with it too. So it makes like a delicious meal.
Ooh.
Stuffed. Amy
Mm.
still hasn't said anything, so.
Are
Are we on question 4 now, or are we still describing the data?
We're on 3. We
Okay.
have to get our numbers.
Let me know what you guys got, because I already got mine.
Okay, I got them.
Perfect.
I just got typing real quick.
1.0556 for
Yeah.
the standard mean difference.
Yeah.
But how do you say it with the D bar? What is the term for that?
The
Mean.
the mean difference, I guess. I don't know.
Okay. And then what do you say for SD? Just sample difference?
Yeah.
Yeah.
Or is that the standard deviation?
Yeah, the sample standard deviation of the differences.
Okay. Well, that one I got -2.596.
See, I think I must have done it backwards on you guys, because I'm getting all positive, but the same answer. So, continue.
And then n equals 9.
Yeah. Okay.
Perfect.
And then we make a histogram.
Boom.
The difference. Okay. So, did it.
All right. So are we all good?
Yep.
So on 4, what type of hypothesis test is appropriate? Well, since we did the not equal to, it has to be two-tailed, right?
Yep.
Is that what it's asking for, though, or is it asking, like, inference for two means paired data test?
No, I'm pretty sure that's what it's asking for.
Oh, okay.
It would have to be paired anyway because you're taking the same 9 people before and after, right?
Uh-huh, because you have the same exact people before and after. And so, it's two-tailed, but yeah, it's a paired sample because you have the same people from both sides.
Okay.
What are the
Requirements.
requirements for this test?
Well, it would have to be a random population.
Yeah, SRS from the population. And then the mean of the differences follow a normal distribution.
Wouldn't it have to be less? I don't know. Never mind.
Well,
Yeah.
the sample size is only 9. So,
Yeah, I'm just saying, wouldn't it have to be like less than or equal to 9? Or something like that? No?
For what?
I don't know. I mean, I feel like it would have to be around the same population size.
no, I just think the population size affects whether we can use certain theories or laws.
Yeah.
I get you. Okay, perfect.
I think for like everything, the most important thing is that there's a simple random sample from the parent population, and then there's some sort of a normal distribution. So for this case, it would be the mean of the differences follow a normal distribution.
Mm-hmm.
All right. So is that the answer?
I think
what the
so.
requirements are? Okay.
Just
So
those
then On SPSS, I guess we need to compute the differences between the two times and determine if the requirements are met for this test. Explain our answers. So C, continue with the test regardless of what you found in part C. Compute the test statistic. Okay.
Okay.
So we have to make another column, right? We have the pre and post, and we have to make the difference column.
Yeah. All right. And so I think we assume that the SRS, that it did draw an SRS, right? That's one
Yeah.
metric. And then for if they're following normal distribution, do we have to make a QQ plot?
Yeah.
Okay. Difference. Okay. Whoa. That's kind of, I don't know. What would you say?
Not too bad.
Not too bad.
I've seen worse. I don't know.
Well, right then, I've seen worse. I don't know. I think it's okay
What'd you guys get?
for the QQ plot.
Yeah.
Is, I don't know.
Dots fairly close.
Yeah, fairly close. Yeah,
All right.
fairly normally distributed. Okay, so the degrees of freedom, n minus 1, so it'd be 8. The p-value to the alpha level.
Well, this second part is kind of long. It just has a lot of questions.
So since it's we have to do the one sample test.
I think it's the paired sample t-test. And that gives you everything you need. Nice.
What did you put in your paired variables? Pre and post?
Yeah, so I just like drug pre over for the first box and then drug the second one over for the second box.
that give you your p, or I guess where's your p-value?
It's under sig two-tailed. That's the p-value.
Yeah, I'm not. Hold on. I think that my screens have to be so little. Oh, okay. And since it's two-tailed, then we don't divide it. So 0.257.
Yeah.
All right. Are you with us, Landon?
Exactly right next to you. That's exactly what I got.
Okay. F, make a decision. Do you reject the null or fail to reject it? It's greater than the 0.05, so we fail to reject it.
Yeah.
And G, present your conclusion in the form of an English statement. We have
Insufficient evidence to suggest that a difference exists.
I'll be right back.
Between pre and post assembly times.
how bad Amy's isn't working.
Yeah.
Should we wait for a second?
Sure.
You guys there?
Yep.
Yep.
Okay.
So on H, rather than testing a hypothesis, now say you just want to estimate the mean difference between wait times at the 95% level. What would you do? Do it and paste your results below.
Would you just look for a confidence interval?
Like the upper and lower.
Yeah.
That's what I think.
Okay. So, what did you get for your interval?
Well, did you do it off the paired sample or from a one sample because they're different. I had done both.
You did what?
I did a one sample test and a paired sample.
Oh, okay.
So I don't know. I mean,
I just did the paired sample. What did you get for the paired sample one?
negative 0.93969 and 3.0508.
Okay, that's what I got.
I guess the one sample is just the opposite of those. You know what I mean? Negative
Yeah.
instead of positive. And vice versa.
Yeah. So for that, we could say because the confidence interval contains a 0, then we could fail to reject the null, I guess.
Okay, so what number are you guys on now?
Letter H.
Okay. For some reason, when I heard you talking about rejecting all hypothesis, I was like, I thought we already passed F. Okay, but that makes sense. Okay.
So this did that. We looked at the confidence interval on the paired sample statistics, the upper and lower, and that's what we would put because we already used a 95% confidence interval.
Yep.
Okay. So 5.
Yep.
In a short paragraph, describe the action you feel should be taken based on the statistical results above.
Basically, don't change anything to the factory.
Yeah. Didn't really change anything, so it wouldn't be worth.
It'd just be a waste of time.
Yep.
Alright, I will pull up the answer key and we can check it.
Amy!
Hey!
You back?
Yeah, I'm back. And the sound is working. Where are you guys at? Just.
We just barely finished part 2.
Yeah, we're just going to go over our answers.
Sorry, you just did what?
We just finished part 2.
Oh, okay. Sounds good.
Alright, so for number 1A, the answer is after implementing the new loading/unloading procedure, is the mean wait time different than the wait time before? And then B is the null is the difference equals 0, and the alternative is the difference doesn't equal 0. And number 2, the researcher collected assembly times in minutes from 9 factory workers before a change, and he collected assembly times for those same 9 workers after the change had been implemented. Number 3, okay, so we have the mean difference is 1.056. The difference of standard deviation is 2.596, and the number is 9. And then there should be a graph, which we did. And then 4A, a two-tailed paired sample t-test for means is the appropriate hypothesis test to perform. And B, we assume a simple random sample of the population. N is less than 30, so we need to make a QQ plot, which we did. The test statistic is 1.22. The degrees of freedom is 8. The p-value is 0.257. F is the p-value is greater than the level of significance, so we fail to reject the null. Let's see, G. We have insufficient evidence to say that the time to make 100 products is any different after implementation of the new assembly procedure. H, we would create a 95% confidence interval using the t-distribution. And then 5, students should describe how they need to find another way to reduce the time because this particular plan doesn't make a statistically significant difference. So, we did good. So, should we start the quiz?
Yep.
Okay.
Where's my bus? You little fella, where you be?
All right, number 3. Are we all there?
Yep.
Suppose we have a
Give
set.
me a second, because my mouse isn't working at all. Come on, little laptop. Do me a favor. Come on, please. I don't know why everything else is...
Are you using a trackpad?
Yeah, but it's on and off. Like, a mouse isn't just showing up at all.
Oh, okay. Try tapping the upper left-hand corner of it.
Come on, little fella. Work for me. Pat, I'm just going to close my laptop real quick and then open it again. So if I'm gone for a second, be back. I'm back. I'm back.
Is it working?
Yeah, got my mouse.
Awesome.
Done. Group meeting, lesson 12.
Alright, so suppose we have a set pair of data, let the difference equal x after minus x before. The null hypothesis is that the difference equals 0, and the alternative is that the difference is not equal to 0, and the population standard deviation is not known. So Jordan collects a sample of 9 and computes the sample mean to be, differences of the mean to be 2.2, and the sample difference standard deviation is 3.3. So, what is the value of the test statistic? And our equation.
Would you mind giving me those numbers again? My computer is kind of reading out right now. I'm not sure what it's doing, but it won't let me load.
2.2
2.
And then the number is 9. And standard deviation difference is 3.3.
Okay, thanks.
So what? How do you find? Are we looking for the t-score, right?
Hmm.
So what do we use for the
I'm
mean?
doing minus 0 over standard deviation difference over the square root of n. Is that wrong? Formula?
So we go. So is it 2.2 minus 0?
Yeah, well, that's what I'm doing.
Okay. Sorry, I was just confused for a second.
Is that right?
I think so.
Did you get 2 for your answer?
Yeah.
1 second. I'm still figuring it out. 2.3 divided by the square root of 9.
Yeah.
Okay.
Yeah, I got 2.
2, okay.
Okay. The probability of being. Did you get that, Landon?
Hang on 1 second. What did you guys get? Sorry.
2?
Yeah, that's what I got. Just making sure.
Okay. So, number 4, the probability of being greater than 2 is 0.0403. Use the alternative hypothesis to determine the p-value for this test. So,
Remind me how we do this?
So the probability of being greater than 2 is 0.0403. So that's like a one-tailed. Do we just multiply that by 2 and then that's our p-value?
You mean divide by 2?
I think multiply it by 2 because, because it says the probability of it being greater than, and the question is asking what's the probability of it being different than,
Yeah.
which would be the two-tailed.
Oh, I see what you're saying.
So that's all we do. We just multiply by 2 and compare it to the hypothesis thing. Alpha.
I can't hear you very well.
So we just multiply it by 2 and compare it to alpha.
Yeah, I think so.
Okay.
Okay.
So 0.0806,
Yeah, or 0.081.
and alpha is 0.05.
I don't know. I don't think we know alpha yet. It's probably 0.05.
So you guys are timesing it by 2.
Yeah,
And then dividing by what?
nothing.
Nothing.
We're just finding the p-value right now.
Oh, so you're just times it by 2 and saying it's 4?
No, we're
No.
times 0.0403 by 2.
Oh, so you're just making it a two-tailed.
Yeah.
Okay, so you're saying it's like 0.806. Like that?
0.081.
Sorry. What was that one more time?
0.081.
Yeah. You're the best.
Okay.
Use the data below to answer questions 5 through 10. Copy and post into your software and make a column of differences. Use a null hypothesis and an alternative and a level of significance. Okay.
Okay. We're going to be using 90% now. Let's see. 1. What is...
I can't remember how I made the difference column.
Go to transform and then compute variable.
Are you just doing 1 minus 2?
Yeah.
Here's the thing, though. Do we make them negative or do we make them positive? Are we doing 2 minus 1 or 1 minus 2?
I don't know. It doesn't really specify that in the question.
Because when you guys went over it, right, all of them were positive, right?
So should we do 2 minus 1? Is that what you're saying?
I'm just wondering, like, because the numbers come out to be the same. It's just a positive or a negative sign.
Yeah.
Question, give us a scenario.
What's that?
Does the question give us a scenario or just use this data to do stuff?
Use the data.
Yeah, it just says use this data for 5 through 10.
But on our homework, it came out positives instead of negatives, and on the homework, we did 1 minus 2. We probably should have done 2 minus 1. I don't know. What do you guys think?
I have no idea.
What's the title of the data? Sorry, it's finally letting me start the quiz now. What's the data?
Hello?
Hello?
Sorry, you guys are just cutting out a lot.
I didn't title the data yet. I just titled the target variable. I just have them as 1 and 2.
Yeah, I just put group 1 and group 2.
Sorry, I was thinking it was data set. I just opened the quiz. Woo!
Hey, sorry, my numbers got erased. I had to restart the quiz because my computer froze. So we got 2 and then .081, right?
Yeah.
Just making sure.
Amy, did you have to restart?
I restarted my computer to get the sound working, but now the internet is really, really, really ridiculously slow. And it won't let me load the remote desktop.
So are we doing 1 minus 2 or 2 minus 1? Ridiculous.
I feel like it should be 2 minus 1, but I don't know.
That's
That's
kind
what
of
I think too.
Okay.
That's
So,
not
minus
bad.
1?
Yeah.
Here. Minus. Oops. Uh-oh. Okay, I don't know if I did this right. So did you guys get like... Oh, hang on. Never mind, I did do it right.
How many questions are on this? Oh my god.
Okay, so the mean difference, did you get negative 31.025?
Yeah.
Okay.
Is that the first question that they're asking for?
Yeah, that's number 5.
Negative 30. How many decimal places?
3.
3.
Okay.
And then the sample standard deviation of difference is 341.157.
Uh.
Seems really big.
Oh, yeah, 341.157.
I guess that's right because there's some numbers that are just giant in there, but it seems
Yeah.
really big.
Okay, so this is a two-tailed test. So we leave it. Let's see. Test. Statistic. Here we go. And
Are you doing the paired sample?
yeah, and I'll just put group 2 in first. I don't know if that makes a difference. %. Okay. -0.407.
Negative 0.407.
Let's go with that.
Okay, I think I got it.
Okay.
Did you guys get negative .407?
Yeah.
Okay.
And then this is two-tailed, so we leave the p-value at 0.689.
Yeah.
Okay, and so when you reject or when you fail the hypothesis, it has to be less than your test statistic. Is that right?
Yeah, to reject it has to be less.
So it failed to reject. That's what we're at right now because it's positive, and the other one's negative.
Yeah.
Yeah.
Are we all on 10?
Yeah.
Suppose your alternative hypothesis is mean difference is greater than 0. What is the correct decision based on this evidence?
0.689 divided by 2 is 0.3445.
So still
we
fail.
still fail, yeah.
All right. I hate these data sets.
Here we go again.
Grab a pillow. Grab a pillow from them. You went on a date making pancakes or something like that with a coworker. Or maybe a dude. Home stretch here. Last set of data. Copy and paste. Hmm? Which one was he? Teen Titans. I got him too. I'll write it down. What you do is you fight him first, and you put him away. His health gets completely regained. In less than a minute. Can you do me a favor? Could you put this in the fridge when you get done?
Are we figuring at 95% still?
That's what I'm confused on right now myself.
I just have too many screens open. I can go back, but
I mean, it doesn't really
It's-
say. That's why I'm confused.
isn't that kind of the assumed unless they tell you different?
Yeah, probably. Okay, so for 11, is everybody there?
Yeah.
Which is greater, N or DF? N?
N for sure.
Awesome.
Hold on, I'm not there, I guess.
Well, the degrees of freedom is just n minus 1, right?
Yeah.
So n should be greater, right?
Oh, I see what you're saying. Okay. N is always greater than DF?
Yeah.
Yeah.
Okay. Your alternative hypothesis is standard difference is not equal to 0. And you use a level of significance 0.01. What is the p-value?
Okay. So are we going to put group 2 before group 1 again?
That's what I'm going for.
Okay.
Yeah.
Oh.
And this is the 99% confidence interval?
Yeah.
When it says 0.01, does that mean a 90%?
99.
Oh, so it's a 99%.
Yep.
Shoot, I did that wrong. Okay, why that kid likes going fishing so much. He's brown.
You're doing the paired sample t-test again?
Yeah, that's what I did.
I can get my thing to come out.
What'd you guys come up with?
I got 0.001.
Well, that makes sense.
So did I.
Okay.
Question, has anybody heard from Amy in the last, I don't know, half hour?
Sorry.
Her computer's giving her problems. Cut her some slack.
Well, I was just wondering, she's there, it's just her face was in the same spot the last time I checked too, so I didn't know if like she glitched out or something. So
Okay.
I'm just using my computer, so I don't need to like get a lot of these answers. Sorry, guys.
So 0.001, what decision do you make?
It's low, so we reject.
Yep.
we reject the hypothesis. We decide to try another alternative hypothesis. Use blah, blah, blah.
Same notes with this.
So instead of two-tailed now it's one-tailed.
So did the p-value increase or decrease? It would decrease, right?
Definitely a decrease.
And we divide it by 2.
Or sorry, still reject.
What decision do we make now?
We still reject, right?
Yeah, because it decreased, it went lower than it was before.
Yeah. Alright, last question. As we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value? Well, wouldn't it either be
Yeah,
greater than or less than?
one of the top two. But we can't select two of them.
Yeah.
Maybe not enough information.
Yes.
Trying to think of this.
Because it wouldn't be just greater than, because then you're selecting the right, and it would be just left than, because you're selecting the left. So,
They're
yeah.
exactly the same.
Yeah.
It doesn't make
Okay.
any sense.
I'm lost with this. I feel like there's not enough information because we need other stuff to figure that out.
So, awesome. I will
I'll
submit.
submit first.
Oh, okay.
If the answers are, I haven't been able to do a lot of this stuff, so I feel so I'm submitting.
How did we do?
Hey, 100%. Woohoo.
Good work.
I wish we could just take the test together.
I know.
That would be very
All right. So does Wednesday at 1 work for everybody?
Yay! Yes.
Alrighty.
You want me to set up the Hangout, or do you want to set up the Hangout because my computer?
Please have you do it. You know how to do it better than I do.
Okay, well,
I
maybe
don't
my
know.
computer will have problems. I'm
Yeah.
fine.
Thanks, Amy.
Yeah, no
Alright.
problem. We'll see you guys Wednesday.
See you guys.
Yeah.
Yeah.